Ah, now we get to the really interesting part. Every atom has electrons. Those electrons are doing two things. First, in some rough sense, they are orbiting the nucleus. They are moving around. A moving charge. That is a tiny loop of current. That is a tiny magnet. Second, and this is the strange part, electrons have something called spin. Now, spin is not exactly like a spinning top. It is a quantum mechanical property. We call it spin because in some ways it acts like the electron is rotating, but you should not picture a little ball twirling around. It is more subtle than that. What matters is that this spin gives each electron a tiny magnetic field of its own, as if it were a little bar magnet. So every electron is like a microscopic magnet, partly because it is moving around the atom, and partly because of this intrinsic spin. In most materials, these tiny magnets point every which way. Random directions. They cancel out. You add up 1 billion tiny magnets pointing randomly, and you get 0. No net magnetism. But in certain special materials, iron being the famous one, something different happens. The atoms line up. Their little electron magnets all point the same direction, at least in patches, in regions we call domains. And when you magnetize a piece of iron, you are getting all those domains to line up together. Now you have billions upon billions of tiny magnets all pointing the same way. Add them up, and you get a big magnet, a bar magnet.